So as we just talked about, in a composition hierarchy, the relationship between a containing class and one of its part classes is known as a has-a relationship. For example, we talked about each human body having a brain and a heart, right? Aggregation is a weaker form of composition. With aggregation, one class is the whole and the other classes are parts of the whole, as with composition, but there is no additional constraint that requires the parts to be exclusively owned by the whole, right? So aggregation is a subset of composition. An aggregation example where the parts are not exclusively owned by the whole can be seen as follows. We could implement a school as an aggregation by creating a whole class for the school and part classes for the different types of people who work and study at the school, right? So for example, we have Park University and we have students, staff, and faculty, right? The people aren't exclusively owned by the school because a person can be part of more than one aggregation, right? I could be a student at Park U and I could belong to a family. I could have a job that I'm a member of. And so those classes could belong to different things. So, for example, a person can teach classes at 2 different schools and be part of 2 school aggregations. In this case, it would describe my situation, right? I'm faculty at both Park University and AFIT, so I belong to both. The same person might even be part of a 3rd aggregation of a different type, like a household aggregation, right? So I have my family, I'm part of that. I'm part of faculty at Park, I'm part of the faculty at AFIT. So I can belong to many different things. Let's take a look at another example, but this time we're going to do it in code. But we're going to set the stage first. So suppose you're trying to model a car dealership with a computer program. And since the car dealership is made of several distinct non-trivial parts, it is a good candidate for being implemented with composition and aggregation relationships. The car dealership's non-trivial parts are as follows. We're going to have a group of cars, right? A sales manager and a group of salespeople. In implementing the program, we're going to define 4 classes: the car, manager, salesperson, to implement the non-trivial parts. And of course, we're going to have the dealership class as well. And the dealership class is going to contain the 3 parts classes. For each of the 3 class relationships, dealership to car, dealership to salesperson, and dealership to manager, is the relationship a composition or an aggregation? Well, it's both. This is a combination of a composition and of an aggregation. The cars belong to the dealership, but what about the salespeople and the manager? Do they solely belong to the dealership? No, they don't, right? They can belong to other things. So let's take a closer look at the UML on the next slide. UML, or Universal Modeling Language, class diagrams show the relationships between a program's classes. A solid line between 2 classes represents an association, or in other words, a relationship between those 2 classes. On an association line, a solid diamond indicates a composition relationship. And a hollow line, or a hollow diamond, indicates an aggregation relationship. The diamond goes next to the container class. The labels on the association lines are called multiplicity values, and they indicate the number of object instances for each of the 2 connected classes. Right? So here this says we can have many cars going to 1 dealership, and we can have 1 manager for 1 dealership. And of course, we're assuming like a general manager, not an associate manager. You can have a bunch of those. We also have many salespersons going to 1 dealership, right? So you can see here that these hollow diamonds are aggregation relationships, right? And the solid diamond is a composition relationship.